Hi everyone, this is the 27th lecture of IE451. Okay, so let's solve problem 7-21. Compute the rate of return for the following cash flow to within 0.5%. Okay. So we are solving problem number 7-21. So we may use present worth of benefit is equal to present worth of cost. Okay. So let's draw the cash flow diagram based on this cash flow table. So there is an initial cost of $640. And then at the end of 2 periods, there is a positive cash flow of 100. At the end of period 3, 200. At the end of period 4, 300. And at the end of period, this should be 5, right? Period 5. There's another 300. Okay. So this positive cash flow can be broken into 2 components. One for the arithmetic gradient for the 4 periods, 0, 1, 2, 3, 4, and 5. So we have 100, 200, and 300, right? And another one that includes the positive cash flow at the end of period 5 only. Okay. Like this. So the present worth of benefit would be 100 and P given G and I% over period 4, right? Plus 300 and P given F I% over 5 periods. Is that right? Of course, the present worth of cost is just $640. Present worth of cost is $640 from here. So we need to solve 640 equals 100 P given G I% over 4 periods plus 300 P given F I% over 5 period. Is that correct? Okay, so you may want to use trial and error methods to find out the interest rate that satisfies this equation. So let's try 15% of interest rate. For 15%. For the 15%, the P given G over 4 periods is 3.786. 100 times 3.786 plus 300 times P given F over 5 periods, that is 0.4972. 4972. So how much is that? That is $527.76. And this value is too low if you compare to this value, 640. Okay? That is lower than 640. So let's try 10%. The interest rate of 10%, P given G over 4 period is 4.378. And P given F over 5 periods is 0.6209. 0.6209. Then how much is this? Okay, this is 624. $624.07. And this value is still lower than 640. So let's use 9% of interest rate. Okay. If it's 9%, P given G over 4 period is 4.511. And P given F over 5 periods, 0.6499. 0.6499. So how much is this? That is 646.07. And now this value is larger than 640. So you may say that the desired value of rate of return is somewhere between 9% and 10%. Okay? So now let's use linear interpolation to find the exact value of I. So let's have a table. That is the rate of return value, and 9%, X%, 10%, and here 100 times P given G, I over 4 periods, plus 300 times P given F, I over 5 period. Okay. If it's I equals 9%, we've got 646.07. If it's 10%, it's 624.07. And we've got here 640 from here, right? So based on this, we can draw a simple diagram. So here 9%, X%, and 10%. Okay. And here we have 646.07 and 640, and down here 624.07. Okay. And here we have 9% and 10% here, and connect these 2 points to make a big triangle. And connect this. You also have a small triangle here. And we call this small triangle A, and large one B. Okay? So our interpolation is based on these 2 triangles. So the height of triangle A is 646.07 minus 640 versus the base of triangle A, that is x minus 9, equals height of triangle B, 646.07 minus 624.07 versus the base of triangle B, that is 10 minus 9. Okay? And the inner product equals the outer product. So here what do we have? X equals 9 plus 646.07 minus 624.07, right? Then here 10 minus 9 times 646.07 minus 640. Okay? So how much is this? Okay. That's going to be 9.276%. Okay. So this is the answer for problem 7-21. Okay, and next problem that we are going to solve is 7-24. Okay, so let me redraw the cash flow diagram. Zero, 1, 2, 3, 4, 5, and 6. Right? So there are 6 periods. And for each period, there is a positive cash flows of $80. And at the end of period 2, 4, and 6, there is a negative cash flows of 200. Okay. And the problem is, for this diagram, we need to compute the interest rate at which the costs are equivalent to the benefits. So if you look at this cash flow diagram carefully, you may see that a certain pattern repeats 3 times. What are they? Here, this is a repeating series. So the easiest way to solve this problem is to solve this just one cycle of a repeating diagram. So in order to compute a repeating, in order to compute a rate of return, you may use present worth of benefit equals present worth of cost. Okay? So here, this one cycle of a repeating diagram is this, right? 200, which is identical to 0, 1, 2, 80, and here 120. Okay. So, of course, you may go with this diagram or this one. That is your choice. Excuse me. So for this, the present worth of benefit is $80 plus no. Okay, here present worth of benefit would be 80 times F given P I% over 1 period plus 80, which is equal to 200. Okay, because at this time what I did is you just convert this 80 to the equivalent future sum at the end of period 2. Okay, and then if that is the case, you can simply add this number, and on the other side you will have just 200. Okay, likewise here you can move 80, convert 80 to the equivalent future value at the end of period 2. So 80 times F given P I% over 1 period is equal to 120. Okay. So in that case, what is this? That is 1 plus I. Okay. So here 1 plus I is equal to 120 over 80, which is 1.5. So in this case I would be 0.5, which is 50%. Okay. Of course, some of you want to convert all this value to the equivalent present sum at the end of period 0. If you want to do that, it's going to be 80 P given A I% over 2 periods equals, also the cost value should be converted to the equivalent present sum at the end of period 0. So 200 times P given F I% over 2 periods. Okay. Same for this diagram. If you want to convert P given A I% over 1 period is equal to 120 times P given F I% over 2 periods. Okay. But in that case, you need to use one more factor, one more table values compared to the previous one. So I would go with this methodology, okay, which is more easier, but you need to think a little bit more. Okay. And what about next problem? Okay, let's solve problem 7-45. A used car dealer advertises financing at 0% interest over 3 years with monthly payments. You must pay a processing fee of $250 at signing. The car you like cost $6,000. What is the effective annual interest rate? And you believe that the dealer would accept $5,200 if you paid cash. What effective annual interest rate would you be paying if you financed with a dealer? Okay, so we are working on 7-45. There is R missing. What is your effective annual interest rate? Okay, so let's work on the part A first. And because the advertisement says 0% interest over 3 years with monthly payments, the monthly payment amount would be calculated. So here 0% interest over 3 years with monthly payment. Right? So the monthly payment is $6,000 divided by how many months? There are 36 months in 3 years, so you need to divide by 36. So how much is that? 6,000 divided by 36. That is $166.67 per month. Okay. And the internal rate of return. Internal rate of return can be computed by setting the net present worth equal to 0. Okay? So, in our case, net present worth is $6,000 minus $250 because you need to pay this processing fee right away. So minus 250 minus the monthly payment, which is $166.67, and you need to convert this monthly payment to equivalent present worth, right? So it's going to be times P given A I% over 36 months. Okay? And this got to be equal to 0. Okay? So here, P given A, I% over 36 periods is equal to $34.50. And maybe here's the situation that we faced. The car price is $6,000, right? And you need to pay the processing fee of $250 right away. And for the next 36 months, the monthly payment amount is $166.67. Okay? And our formula, our equation is based on this diagram. Okay? So anyhow, we've got this vector value of $34.50. So what's next? The compound interest tables in Appendix B of our text does not go to a low enough interest rate. So we must solve (1 plus I to the power 36 minus 1 over I times 1 plus I to the power 36 equal to 34.50. Okay? So we need to solve this equation because our textbook, the compounded interest table, does not provide this interest rate. Okay? And this equation can be solved by trial and error method, or actually you can use Microsoft Excel, MS Excel, using the IRR function. Okay? So in this class, we've never discussed how to use Excel spreadsheet for engineering economic analysis. However, spreadsheet can be used in most real-world application problems of engineering economy. So if you use Excel, then the Excel is I would be 0.00232 or 0.2320%. Okay? So in this case, the effective annual interest rate would be I sub A equals 1 plus 0.00232 to the power 12, because there are 12 months in a year, minus 1. So how much is that? Okay, that's going to be 0.0282, which is 2.82%. Okay, so there is the answer for part A. The effective annual interest rate is 2.82%. Now, how to answer for part B? The fact that the dealer would accept $5,200 cash for the car indicates its true worth, right? So the extra $800 is a hidden finance charge, right? So $6,000 minus $5,200, which is $800, and this extra $800 is a hidden finance charge. Okay, because your monthly payments are still based on the original car price of $6,000, but the true worth of the car is $5,200. We may have net present worth would be 5,200 minus 250 minus 166 and 67 cents times P given A I over 36, right? So here's the new situation. The car price is not the price, but is really worth $5,200, and you're going to pay $250 right away, and for the next 36 months you're going to pay $166.67 each month, right? So the net present worth can be computed in this way. Okay. So here, P given A, I over 36 is equal to $29.70. Okay. And actually in this case, if you use the linear interpolation, you will get I equals 1.081%. Okay. So I'm not going to go through all the details about the linear interpolation because we are running out of time. But I want you to double check this value. Okay. Okay, so in this case, the effective interest rate would be 1 plus 0.01081 to the power 12 minus 1. Okay. So in that case, you will get 13.77% of effective interest rate. Okay, 13.77%. So that is the answer for question B in problem number 7-45. Okay. Then what about problem 7-47? A used car dealer advertises financing at 4% interest rate over 3 years with monthly payments. You must pay a processing fee of $250 at signing. The car you like cost $6,000. Then what is your effective interest rate? You believe that the dealer would accept $5,200 if you paid cash. What effective annual interest rate would you be paying if you financed with a dealer? I think this problem is very similar to the previous one, problem 7-45. Looks like only the difference is this time the dealer offers 4% interest, 4% finance instead of 0%. Okay, and we have one more question. Compare these answers with those for problem. Sorry, this is problem 7-45. Okay. What can you say about what matters the most for determining the effective interest rate? Okay. Okay. So we are working on problem 7-47. So like I mentioned, the only difference this time the dealer offers 4% finance instead of 0%. So first we need to determine monthly payments for the loan. So if you use I equals R over M. So R is 4% and M should be 12 because there are 12 months in a year. So this is the 1/3, which means 0.3333%. Okay. So this is the monthly payment. So now we have A equals $6,000, A given P, 0.3333% over 36 months, right? And the other expression is like 0.003333 times 1 plus 0.003333 to the power 36 over 1 plus 0.003333 to the power 36 minus 1. Okay. So how much is this? So this is going to be $177.14. $177.14. So here the car price is $6,000, and you need to pay $250 right away, and for the next 36 months monthly payment would be $177.14. Okay, from this. So again, we're going to use this criterion, net present worth equal to 0. Okay. So in our case, net present worth would be 6,000 minus 250 minus 177.14 times P given A I% over 36 months. Okay, equal to 0. So P given A I% over 36 months would be $32.46. Okay, And next step is to use linear interpolation. And then you will get I equals 0.572%. Okay? So in that case, the effective interest rate I sub A would be 1 plus 0.00572 to the power 12 minus 1, which is 7.09%. So this is the effective interest rate, which is the answer for question A in problem 7-47. Okay. Then what about question B? So the worth of car is $5,200, right? Which is from 6,000. $5,200. And the payments are determined by the actual cost to buyer, which is $6,000. So the monthly payments are the same as before, right? Same as above. So net present worth would be, based on this cash flow diagram, the worth of the car is $5,200, and you need to pay $250 during the signing, and for the next 36 months there is a monthly payment of $177.14, right? So the net present worth is 5,200 minus 250 minus 177.14. P given A, I over 36. So P given A, I over 36 period would be, from my previous calculation, 27.944. Okay. Again, if you use linear interpolation, I would be 1.44%. Okay. Again, I'm not going to go through all the details of this linear interpolation procedure because it is time consuming, and we've already done many times, so you should be able to do this by yourself. So please double check this value at home. Okay. So in this case, the effective interest rate would be I sub A equals 1 plus 0.0144 to the power 12 minus 1, right? It's 0.0144. Okay, so we're going to have 18.72%. So this is the answer for part B in problem 7-47. Now, how do you answer for part C? Compare these answers with those for problem 7-45. What can say about what matters the most for determining the effective interest rate? So I would say that the actual value of the car seems to be the most important factor for determining the effective interest rate. Okay. Okay. Then the next question that we are going to solve is problem 7-48. Some laboratory equipment sells for $75,000. The manufacturer offices financing at 8% with annual payments for the 4 years for up to $50,000 of the cost. The salesman is willing to cut the price by 10% if you pay cash. What is the interest rate you'd pay by financing? Okay, so we are solving problem 7-48. The amount of cash paid, is 75,000 minus 50,000, right? Which is $25,000 with 50,000 financed. Okay. So the monthly payments would be 50,000 times A given P, 8% over 4 periods. So what is this table value? %, A given P over 4 periods is 0.3019. 0.3019. So what is the monthly payment amount? Okay, that's going to be 590 and 15. So it's going to be $15,095. Okay, that is going to be the monthly payment. And if you pay entirely in cash, the reduction in cost if you pay entirely in cash, the reduction in cost would be $7,500. Why is that? In such case, the salesman is willing to cut the price by 10%, right? So this came from 75,000 times 10%, which is 0.10. Okay, that's gonna be $7,500. So 100% cash payment would be 75,000 minus $7,500. How much is this? It's going to be $67,500. So this is the true value of equipment. Is that correct? $67,500 is the true value of equipment. Now we can build up a cash flow table based on all this information. So we are considering how many years? From 0 to 4. I'm sorry, 0, 1, 2, 3, and 4. Okay. And I'm going to put pay cash, the first column. So here I'm going to put the true value of equipment, which is $67,500 from this. Okay. Okay, and then next column, I'm going to put borrow from manufacturer. So here at the end of period 0, we're going to put $25,000, right? And then the monthly payments. Here we put $25,000, and the monthly payments would be $15,095. Okay. So we need to put $15,095 each. Okay. So here, the incremental difference would be this value minus this would be negative 42,500. And we have 0 all down here. The 0 minus this would be 15,095. And same for the others. $15,095. Okay. Now we can get the net present worth equal to 0, which is negative 42,500 plus, you need to convert this uniform series to the equivalent present worth. So $15,095 times P given A, I over 4 periods. Okay. So here we have P given A, I over 4 periods equal to what value? Here we have 2.816. Okay. And next step is again using the linear interpolation. You will get I equals 15.72%. Okay, 15.72%. And that's going to be the answer for problem 7-48. Okay. Okay, so I'm going to stop here for today. And next time we're going to continue to solve the end of chapter 7 problems. Okay, thank you. Bye-bye.